Now, let's get the velocity. The speed v is equal to this d over the time, which is the 5 minutes. So you have the 2666.91 divided by 5280 and divided by 5 minutes. And let's convert the 5 minutes to hours. So you have the 5 over the 60. Then you compute. Finally, get the answer that is approximately equal to 6.06 miles per hour. And this is the speed at which the leading edge of the file is spreading.
When you enter that in your calculator, it should be a degree mode?
Yes,
Okay.
you should use the degree mode. Or either way, you may first convert this degree to the reading measure and then use the reading mode. If you want, okay, if you prefer the reading mode.
Oh no, I had it in degree. I just wasn't getting there.
Okay. Other question? We know in section 5 we learned the inverse trigonometric functions, right? So the one of the most important things about the inverse trigonometric functions is the domain and the range of all those 6 trigonometric functions. And for the sine, we restrict this sine function to this range, right? And so the to this domain. And so the range of the inverse sine is equal to this restricted domain from the negative half pi to half pi. So that means when you use the inverse sine to get a value, then your inverse sine value must be in this interval. For example, we know, let's see, we want to find the sine alpha. We want to find the alpha for which the sine alpha is equal to negative 1/2. Although we know the sine of the pi plus the pi over 6, this is equal to negative 1/2, right? Because the reference angle of this pi plus the pi over 6 is the pi over 6, right? And the sine, the SHN of the sine function in the quadrant 3 is negative, right? But you cannot say arc sine is equal to pi plus the pi over 6 because this angle is not in the range of this arc sine. You must find an angle which is in this range. Then you can find the right arc sine value. So actually the arc, sorry, this should be, let me insert this negative 1/2 here. So we're talking about the arc sine of the negative 1/2. So the arc, so this guy is not, right, is not equal to this pi plus the pi over 6. So the arc sine of the negative 1/2, this should be equal to the negative pi over 6. Because we know the sine of the negative pi over 6 is equal to negative 1/2. And also this negative pi over 6 is in the range of this arcsine. Is in this closed interval from the negative half pi to half pi. Okay, so this is about the range of all those inverse trigonometric functions. And for the cosine, the range of the arc cosine is the interval from 0 to pi, right? And for the arc tangent, its range is from the negative half pi to positive half pi, right? And for the cotangent, its inverse, the range of its inverse function is from the 0 to pi. And for the secant, cosecant, which is similar to the range of the cosine, the arc cosine and the arc sine, except you need to exclude the point at which the cosine and sine is equal to 0. So this is about the range of the inverse trigonometric functions. And I know you found the problem of the finding the inverse function is kind of hard, right? So right now let me show you one more example to see how we find the inverse function of a trigonometric function. And let's go to the page 487 and let's look at the problem 1 in this pop quiz. So find inverse f of x if the f of x is equal to cosine of 2x for the x between the 0 and half pi. So in this problem, since x is between the 0 and half pi, then we know the 2x is between the 0 and pi. So the x is in the restricted domain of the cosine, so that when we restrict the cosine to this domain, this restricted cosine is a 1-to-1 function, so it's invertible, and then we can find the inverse. Now let's get back to the whiteboard. So we have the function f of x equal to cosine of 2x. And then we need to find the inverse. So we just use the y to replace the f of x. And then we switch the rows of the x and y. Then we get x is equal to cosine of 2y. And last time, I justified the steps at which I can use the inverse function to solve the equation for y. But in your exercise, you don't need to do this, because when we have the problems, this x and this y must be in the corresponding desired the range and domain. So you don't need to worry about the domain and range, just taking the inverse function of the both sides. So right now we can take the inverse cosine of the both sides of this equation, and then you get arc cosine of x equal to 2y. Okay, by definition of the inverse function. Then you divide both sides by 2. Then you get y equal to 1/2 times arc cosine of x. Then in this way, we find the inverse function of the ranging function. So you write the inverse f of x is equal to 1/2 times the arc cosine of x.